noticed how when you're reading like a really good book and you get to a sentence and it just makes sense because you remember what came before?
Oh,
It's
absolutely.
like that aha moment when the pieces connect.
Yeah, yeah.
That's your brain's memory at work.
Right.
And it's something traditional neural networks, those things everyone's talking about, they've really struggled with that for a long time.
Yeah, they did. It's true. It's like they were stuck in this tiny little loop, just processing information in isolation.
Like they've got blinders on.
Exactly. Blinders on, just looking at one word at a time.
And no clue about the whole story unfolding around it.
Exactly. They totally
Yeah.
missed the context. It's like trying to understand, like, a whole movie, but you're only allowed to see one frame at a time.
Just a snapshot.
Yeah, you lose all the good stuff, the plot, the characters.
You need that whole sequence of events.
Exactly.
Thankfully, though, some brilliant minds figured out a way to fix that. And that's where these things called recurrent neural networks come in. RNNs, yeah. They're like the gossip queens of the neural network world. They love to pass information along.
That's such a good way to put it. Imagine this, right?
Yeah.
You've got information flowing through an RNN. It's basically like a chain of whispers passing through a crowd,
Oh, juicy.
right? And each person, they add their own little spin to the story as they pass it along.
Adding their own drama.
Exactly. So by the end, you've got this whole, like, evolved narrative. And that, in essence, that's kind of how these RNNs work. They have these special built-in loops
Okay.
that let information persist, creating this sort of memory within the network.
So no more neural networks with amnesia. I like it.
Right. Exactly.
But what's the big deal about this whole memory thing? How does it actually, like, play out in the real world? Why should we even care?
That's the cool part. This breakthrough, it allows machines to finally understand the relationship between things that happen over time. Think about it with language. We don't just process individual words, right? We get the whole sentence, the paragraph, the entire conversation. RNNs, they help machines do the same thing.
It's like they're finally joining the conversation, not just eavesdropping on random words.
Precisely. They're part of the party.
Okay, so RNNs are sounding pretty awesome so far.
Right.
Like the upgrade we've all been waiting for.
Definitely.
But like any good upgrade, I have a feeling there's always a but coming, right?
You're catching on quickly. You're right. There is a but.
Yeah.
While RNNs are really great at handling these short sequences, they kind of like stumble when it comes to remembering information over a really long period.
Oh, so they're like the friend who remembers the appetizer you had but completely blanks on the main course?
That's a perfect way to put it. It's like they got the gist of the conversation, but forgot all the important details that make it actually interesting.
So close yet so far. That doesn't sound super helpful if they can't remember the good stuff.
It's a real challenge, especially when we're talking about these like really complex tasks. Like imagine trying to summarize a super long document or like having a machine try to have a meaningful conversation with you. It's not going to happen effectively if they can't remember those crucial details.
They need that long-term memory.
They do. They do. That's where we need to bring in the big guns.
Okay, lay it on me. What are the big guns?
The big guns are long short-term memory networks,
Long short-term memory.
or LSTMs for short.
Oh, okay, LSTMs.
These are like the superheroes of the RNN world,
Yeah.
specifically designed to tackle this whole long-term memory problem head-on.
Okay, I'm intrigued. We've got the who and the why, now I need the how.
Of course.
How do these LSTMs actually work? What makes them so different?
Picture this. You're building a supercomputer, right?
Okay.
But instead of just focusing on making it like crazy fast at processing information,
Uh-huh.
you dedicate a whole section to just memory, like storage and management.
Dedicated memory.
Yes. That's essentially what an LSTM is doing. It's
Oh.
like this high-tech filing system that can not only store tons of information, but also actually decide what's important to keep, what can we toss out, and what needs to be retrieved later on.
So they're like the, what's her name, Marie Kondo of neural networks.
There you go.
Tidying up all our information, making sure we can actually find what we need when we need it. That's the idea. But instead of sparking joy, LSTMs are all about holding on to information that's actually relevant to the task at hand.
Makes sense. So how do they do that?
With a really cool mechanism called a cell state.
Cell state. Okay.
Yeah, think of it like a conveyor belt.
A conveyor belt. Okay.
Yeah, that runs right through the network, carrying these vital pieces of information along as it processes the whole sequence.
So instead of just looking at one word or one phrase like in isolation, this conveyor belt lets the LSTM keep track of the entire story as it unfolds.
You got it. Exactly. It's like when you're reading a really good book
Yeah.
and you're jotting down key points as you go. Oh, yeah, like a running notepad.
Right. You might not remember every single word, but you get the main idea, right? The plot, characters, those important details.
That's what the cell state does for the LSTM.
Exactly.
Okay, this is blowing my mind. But how does the LSTM know what to write down on that notepad? And like what to erase to make room for new stuff?
That's where things get really, really clever.
Mm-hmm.
LSTMs use these things called gates.
Gates. Okay.
Yeah, to control the flow of information, like into and out of that cell state, that conveyor belt we were talking about.
So the gates are like the bouncers of this whole operation.
Exactly. Guarding that conveyor belt, making sure only the most important information is getting through.
Love it. Okay, so tell me more about these neural network bouncers. How do they decide who's worthy to pass?
So you basically have three main gates in an LSTM. You've got the forget gate, the input gate, and the output gate.
Okay, 3 different gatekeepers. I'm ready to meet them. Let's start with the first one, the forget gate. What's its role in all of this?
The forget gate, that's like your expert declutterer.
The Marie Kondo.
Exactly. It looks at the information that's already on that conveyor belt, that cell state, and it's like, okay, what's not relevant anymore? What can we just toss out?
Out with the old.
Yeah.
Gotta make room for the new.
Yeah, exactly. Just like cleaning out your closet, getting rid of that shirt you haven't worn in like 5 years.
It's gone. So no more information hoarding with these LSTMs. I like it. But what about the input gate then? What's its specialty?
The input gate, that's all about adding new information into the mix.
Okay.
It looks at the incoming data and decides, okay, what's important enough to be added to our cell state, our trusty conveyor belt.
So it's like we've decluttered, now we're going shopping for new clothes, but we're being super picky about it.
Exactly. We only want to add the pieces that really matter.
The ones that spark joy. I had to. Okay, so we've met the declutterer, the savvy shopper. What about the last gatekeeper, the output gate? What's its role in all this?
The output gate, think of that as the one in charge of presentation.
Yeah.
So it takes all the information that's been so carefully curated on the cell state, on that conveyor belt, and decides what actually needs to be shared with the next part of the network.
So it's like coordinating the perfect outfit. We've decluttered, we've shopped carefully, now it's time to put together a look.
There you go. That's a great way to put it. Choosing just the right pieces to make an impact.
It's like these LSTMs are becoming fashionistas before our very eyes. But this whole system, I mean, it's super impressive, but it also sounds incredibly complex. Like building one of these things must be like rocket science.
It is complex, definitely. Yeah. But the beautiful thing is, we don't have to build every single one of these from scratch.
Oh, good.
Researchers have already developed all these amazing variations of LSTMs.
Oh, okay.
Each one is kind of fine-tuned to be really good at a different task.
So like different models of a sports car. Some are built for speed, others for handling.
Exactly. And you pick the one that best suits your needs.
I'm following. So no one-size-fits-all, LSTM. Tell me more about these variations. How do they actually differ? So many options. So with all these different LSTM models, each with their own strengths, how do we know which one to choose for a specific task? Is there some kind of secret code book or something?
I wish. If only it were that simple. It really often comes down to experimenting.
Trial and error.
Yeah, you try out different variations, see what sticks, you adjust the settings, tweak things here and there, and see what gives you the best results for that particular problem you're trying to solve. Kind of like, fine-tuning a musical instrument.
Oh, interesting analogy.
Yeah, you got to adjust and tweak until you get that perfect sound.
I like it. So it sounds like a lot of trial and error goes into it.
It does.
But the potential payoff, I mean, it sounds huge. I can already see how these LSTMs are changing things.
Oh, yeah.
Giving machines this ability to understand and process information like we've never seen before. But what does it all mean for us in our everyday lives? How will these advancements in RNNs and LSTMs actually impact how we live, how we work, how we interact with the world around us?
That is the question, isn't it? It's the big one.
Mm.
Imagine a world where machines can not only, understand our words, but also actually get the nuances of language. Like, truly understand.
Mm.
Think about it. Chatbots that could actually have a back-and-forth conversation.
No more canned responses.
Exactly. Or virtual assistants that just get you, from like one sentence.
They actually understand what you want.
Exactly. No more repeating yourself like 10 times. And the thing is, LSTMs, they're already powering these technologies.
Yeah, they are.
Yeah, they're making them so much more intuitive, actually helpful. And that's just scratching the surface.
What else could be out there?
Imagine real-time language translation that's so good you'd think a human did it.
No more clunky translations.
Exactly. We could break down so many barriers between cultures. Or think about personalized education that adapts to every student's learning pace.
That would be incredible. Everyone learns in their own way.
Exactly. The possibilities really are endless when you start thinking about it.
It's like we're living in a sci-fi movie, but it's actually real life.
It is.
Mind-blowing.
Yeah.
And to think the impact this could have, I mean, on everything. Education, healthcare, communication.
Absolutely. And here's the other thing. It goes even deeper than that. Because by studying how these machines, these LSTMs, learn to remember how they process information, we might actually unlock some secrets about our own brains, how we think.
Wow.
It's like holding up a mirror. We could understand so much more about how we learn, how we remember things.
So we're not just building smarter machines, we might be unlocking a deeper understanding of ourselves in the process.
Exactly.
That's an amazing thought.
And as we keep going, exploring this incredible world of neural networks, long-term memory, who knows what other mysteries we might unravel.
It's an exciting time to be thinking about AI. Well, we went from neural networks that basically had amnesia to these super-powered LSTMs that are already changing the world around us.
I know, right?
It's been a wild ride. To all our listeners, we hope this deep dive into LSTMs has your brains buzzing.
Absolutely.
And maybe even spark some of your own curiosity about the future of AI. Until next time, keep those minds exploring.